All right, let's talk about bananas, but maybe not in the way you're thinking. We're going to peel back the science on one of the world's most popular fruits to uncover a surprising, kind of glowing secret.
So let me just ask you something. Is your breakfast radioactive? I know. It sounds like a question straight out of a sci fi movie, right? Not exactly something you ponder while you're slicing up some fruit for your cereal. But it's a real question. And the answer, well, it might just surprise you.
Okay, so the short answer? Yup, it is. And it's not just the banana. It's the potato, the nuts you snack on. They're all naturally just a tiny bit radioactive. But hold on. Before you start clearing out your pantry, let me just say this is perfectly okay. It's completely normal and totally harmless. And today we're going to get into exactly why that is.
So to get our heads around this, we've got to, unpeel the science. We're going to look deep, deep inside that banana all the way to the atomic level. And it all boils down to one specific element that you've definitely heard of before.
Right. So everyone knows bananas are loaded with potassium, yeah? It's awesome for your muscles, your nerves, the whole shebang. Well, it turns out that a tiny, tiny fraction of all the potassium in the universe is a special version, an isotope, called potassium-40. And this isn't something weird or man-made. It's been here since Earth was just a big ball of rock. And when I say a tiny fraction, I mean really tiny. Check this out. A whopping 99.99% of all natural potassium is totally stable. That radioactive version, potassium-40, it's just 0.01%. Just 1/100th of 1%. It's practically nothing.
So what does radioactive even mean in this case? Well, it just means that little atom is a bit unstable. It's got a little too much energy. And over a super, super long time, that unstable potassium-40 atom decides to chill out and become stable. When it does that, it lets go of a tiny little burst of energy, and that's the radiation we can measure. It's like a tiny atomic sigh of relief.
Okay, so we've established there's some radiation, but the big question, the one that really matters is how much? To figure that out, we need a bit of perspective. And believe it or not, there's a unit of measurement designed for this exact thing. This is where scientists got kind of brilliant and fun. They came up with something called the banana equivalent dose, or BED for short. It's not a super formal, stuffy scientific unit. It's a way to explain these really small doses of radiation to all of us in a way that just makes sense. All right, let's get into the nitty-gritty. Eating one banana gives you about zero point 0.1 microsieverts of radiation. A microsievert is 1/millionth of a sievert, which is the standard unit. So we're talking about an incredibly small number here. But what does zero point 0.1 microsieverts even mean in the real world? How small is it really? And this is where it all clicks into place. Context is king here. That tiny zero point 0.1 microsieverts from a banana, it's basically nothing compared to other things you do. Taking a cross-country flight, you're getting exposed to about 40 microsieverts from cosmic radiation. That's like eating 400 bananas at once. And a simple chest x-ray, that's about 100 microsieverts. You'd have to eat 1,000 bananas to get that dose. Suddenly, the banana doesn't seem so scary, does it? Now, the banana gets all the press. It's the poster child for this whole thing. But it is definitely not alone. It's part of a much bigger and surprisingly common glowing food family. Yeah, the rule is actually super simple. If a food is packed with potassium, it's going to have a little bit of that potassium-40 isotope, and that means it's going to be just a smidge radioactive. It's just a basic property of the element itself. So you know what that means. Potatoes, beans, nuts, carrots, even red meat. Yep, they're all in the club. Oh, and here's a great piece of trivia for you. One of the most radioactive foods out there is the Brazil nut. Why? Because it's got potassium-40 and its roots are really good at absorbing trace amounts of radium from the soil. But, and this is the important part, even with Brazil nuts, the dose is still completely, totally safe. Okay, so if all this food is slightly glowing, why aren't there warning labels on everything? Why isn't this a massive health crisis? Well, this leads us to the most important point of this whole explainer. The reason it's not a big deal is because this isn't something new or foreign. It's the world we evolved in. See, we are constantly bathed in what scientists call background radiation. It's coming from the dirt under our feet, it's raining down on us from space as cosmic rays, and yep, it's in the food we eat. It has always been here, and it's a perfectly normal, harmless part of just living on Earth. And here's where the story gets really, really cool. That little bit of potassium-40 in your banana, it has an incredible history. It wasn't made here on Earth. No, it was forged billions of years ago in the heart of exploding stars, supernovas. That stardust was scattered across the galaxy, eventually becoming part of the cloud of gas and dust that formed our planet. So when you eat a banana, you are literally eating a little piece of stardust. How amazing is that?
On top of all that, our bodies are just brilliant. We have this built-in system that keeps the amount of potassium in our system perfectly balanced. It's called homeostasis. So when you eat a banana, your body takes the potassium it needs and just gets rid of the excess. That tiny radioactive bit, it just goes along for the ride. Our own biology is what makes the glowing truth of our food so fascinating, and not at all frightening. So at the end of the day, the whole banana equivalent dose thing is a fantastic lesson. It teaches us that dose and context mean everything. It's not enough to hear the word radioactive and panic. The real question is always, how much? And that kind of makes you wonder, doesn't it? What other scary science out there is really just misunderstood?